Artificial intelligence, knowledge representation and reasoning. So in our 2-3 lectures on this, we have seen the detailed concept and tried to understand this the concept in knowledge representation and reasoning. I'm literally sorry for forgetting the afternoon lecture of SCPM. I was busy in meeting, and so exam duties, PhD exam duties. Okay, so that's why the SCPM lecture was gone. Something. Uh, so let's start with this. Okay, am I audible to everybody? Yes.
Yes, sir.
Okay. So today we are going to see this knowledge representation and reasoning. Okay, in its bit detail. So now we going by what you can say book definition. So what is knowledge representation? Okay, it is just a sub area of artificial intelligence, and this uses knowledge representation that is can use to means it's a sub area of AI concerned with understanding, and this can be used by the computer or what we can say program, generally called as agent, artificial expert knowledge base agent, to derive information that is implied by it. I'm going to change the color. Then it can be used, knowledge representation can be used for converse with people in natural languages. Means you can create a computer program or a robot which can converse with the people. For example, if you see the example of Sophia robot, if you go on Google and if you search for the Sophia robot, you will see that. Then to decide what to do next, that also a knowledge representation can be used. Okay. Again, these are the same thing. But when we say what to do next, means we are saying the immediate things. Okay, means saying in a game, a player is playing something, human player, and then computer decides based on that immediately. And future plan means when we say year plan or something. That's why these 2 points are given like this. And then there are some problems which require some human expertise which can be solved using knowledge representation by the machine. Now just take an example of this by machine, what this thing can be. I just want to open the slate. It's a plain PDF file on which we can go on discussing the things. Okay. So sleep, we are going to see this point. We first will try to explore this to solve problems in areas that normally require human expertise. Okay, so consider here you are having soap cases. Okay, this is a soap case, and this again the another soap case. The only thing is that consider this soap case is filled with soap, so it has some weight. This is not. Now, what a human expertise require here, that is, if I want to classify this, if I want to classify these two on conveyor belt, so that I can have only the soap which is correct, so which can be marketed or which can be sellable. So how you will go on doing the knowledge representation? First, you will have a complete what you can say data set. Now this complete data set will have some labels, something like say what we call this as the information. Okay, and then we get the relations with this information related to this, and what we call this as a knowledge. Now this knowledge representation then can be inputted. For example, here you are having say serial number, then dimension, that is height, width, length, because showcase is generally 3D in diagrams. Okay, everything will be there, and the weight. Okay, and weight. So what we'll have here on this conveyor belt, you will have the weight sensor, which will weigh that particular soap. Whenever that soap passes on this, the weight sensor will say that is okay, there is some weight here, and that weight is equals approximately with the soap weight. So this is a correct one. Okay, so this weight sensor will give the signal to a blower. Just consider you are having a blower here. Okay, to a blower. So if there is no weight, blower will have what you can say air. So when this air will strike with an empty soap case, this soap case will automatically fall down from the conveyor belt. Okay, so if weight is there, if weight is there, circuit will break, so blower will stop. If weight is not there, circuit will complete, blower will start. And what you will get? This. So this is the artificial intelligence. Simply using not based on this knowledge representation, because when we represent this knowledge, we know what formula we can have, what type of things we can have. So when we say that is to solve problems in areas that normally require human expertise. So where you require human expertise, there you can have this knowledge representation thing which can be used. Then what is reasoning? Just a minute. Even if you go with this, okay. So what is reasoning? I'll just make this a little bit smaller so that. So deriving information that is implied by information already present in the form of reasoning. So knowledge representation schemes are useless without the ability to reason with them. So knowledge representation and reasoning, this KRR is very important. Now what is reasoning? Say suppose I am having say a sugar here, sugar crystal, and I'm trying, so I have to eat these. So what you can say, you have some relation with the sugar. Let's say that eat relation with the sugar is there, and you are eating the sugar. Now why you are eating the sugar? There we are giving certain type of thing, the otherwise food and likewise. So we have the connectivity, and that is what you can see the reasoning. So whenever you have this knowledge why these things are there, why you require to check the weight, that is a reasoning. For example, if you see this, here we are checking the weight of this, but why we are checking the weight? To check whether it is empty or not. So if you go with the flowchart type of things and drawing something, we can say that if weight, so that is a reasoning thing. If weight equals to true, okay, keep on conveyor belt and turn off the blower. If weight equals to false, okay, turn on the blower and throw from the conveyor belt. So that is what we call as a reasoning. So it is a something like conditional things or a decision making thing, that is whatever the information that you are having, that information should have to be combined together to show certain type of what you can say reasoning and likewise. So have understood this? I think you people understood this thing. So manifesto of this knowledge representation and reasoning is what we could say that program has a common sense if it is automatically deduce for itself a sufficiently wide class of immediate consequences of anything it is told and what it already knows. So that means a program just like us. When we drive on a say when you drive a bicycle, what generally happens? Let's consider this. What a program can do means what? Let's say here you are on a road. This is the road, okay, and here you are on your bike, and your bike is going in this direction. In this direction. So suddenly, say, suppose if you notice or what you can say roadblock or what you can say speed breaker, then you notice the say other bike going through in different direction. Okay. At the same time, you notice a passerby here. Okay, a passerby who is just walking randomly and he is not having any attention towards you. So what happens? Say suppose here you are having the speed of say 60 kilometer. You will observe all these things. You will reduce this speed automatically to 40. Okay. You will apply brake at this juncture. Okay. At this juncture, and what will happen? Your speed will reduce something to 20 kilometers. So you will pass this hurdle without any jerk. You will not harm the person on the road. At the same time, you will not collide with the other vehicle which is just passing perpendicular to you. Okay. So now just consider here instead of you, this motorbike itself is equipped with such intelligence. So how we do this? Hello? It's just passive presence is not what you can say consider. What how we do this? Yes.
Yes. Sir, can you repeat the question, sir? Please.
इस सिंपल एक्सप्लेनेशन हम बाइक चला रहे हैं तो हम रास्ता जो देखते हैं वो कैसे देखते हैं
We see hurdles present on
या पर
the roads.
कैसे कैसे देखते कैसे
Sir, we follow the two white lines
ओके
given on the road
नो
for
नो नो नो
The
particular
lanes,
routes.
the
very
lanes, and
simple you are going
Yeah.
you are actually thinking very complex solution it's very easy solution हम कैसे देखते हैं आंखों से yeah yeah so what if I want a machine to see what I require
a
वो मशीन
camera.
हाँ कैमरा वो मशीन को मुझे आंखें देनी पड़ेगी दैट वी कॉल एज कंप्यूटर विजन okay so now what these cameras will do camera will collect the information just like our eyes are collecting the information but the information is processed somewhere else that is the computing that is our brain now here the camera will catch the information and it will communicate that to the brain. Obviously, to have a very fast communication, brain need to be attached to that particular camera. So, if it is a very remote type of thing, it may have some you can have a delay in that, and in that communication delay can cause something that is to reduce the speed from 60 to 40 within this span it may go for this and so you may reduce your speed to 20 somewhere on this hurdle and that make the speed of your bike may harm a pedestrian or you may get collide with the other vehicle. So these decisions need to be taken very fast. So when we say automatic decision making, a program is what you can say is having a common sense means this program is having the camera compared to the machine. Camera capture the entire environment. At the same time, camera will having the it's not capturing what you can say one time like photo shoot. It is a continuous scanning. So this you have the first photo frame, then you have the second photo frame, then you have this third, and likewise. So you are actually recording everything, and while recording, every photo frame get compared with the new one. Every photo frame get compared with the new one to find out what the errors, or what you can say, the addition into the particular photo. So you know that is this person is there, not in this photo frame, but now hurdle is in this photo frame. Next photo frame may have this person, and likewise. And when these things happens, these objects are clearly observed at the brain side, that is at a processor where you are in a computer program which actually process the captured images, what we call as a computer vision or image processing. Okay, and it will do that data. When this data is saying, that is say, okay, this hurdle is there, it may be of on this many of much of distance, and likewise, and it's quite a complex mathematics involved. But when you create such a program, what will happen? This machine, without a human intervention, can drive itself without harming itself or anybody in the environment. Okay, so that is what these KRR simple thing is, that a program has a common sense. If it automatically deduce for itself a sufficiently wide class of immediate consequences of anything it is told and what it already knows. मतलब हम जब छोटे बच्चे को बोलते हैं कि कूद जाओ नीचे, से सपोज चाइल्ड इज देयर, okay, and if you ask him to jump, then that child will jump trusting you. Okay, but let's consider that there is nobody there, and now child need to come down, and there is no other way than jumping. So what the child will do? Child will calculate everything, that is, if he jump, what will happen, what are the other possibilities, is it okay to climb down, likewise, instead of jumping. So all possibilities will check by that particular child. In the same way, the machine can check by just observing or collecting the data. So in order to program capable of learning something, it must first be capable of being told it. Okay, तो हम जब मशीन बनाते हैं KRR में और AI में, theoretically we consider that is we require to go through all those what you can say thing. So when we say a program with a common sense is a data centric program, what we now call as a machine learning algorithms, which can do certain things just by observing the data, which can do certain things just by observing the data, just like a human being. Means it can convert data into information into relations, and then the knowledge, and then this knowledge represented can be reason or can be used for decision making. So this is the manifesto, or what you can call as the simple fundamental of the knowledge representation. Now, what is the difference between knowledge and belief? Okay, the thing there is knowledge justified true belief. Now, what is belief? Let I am talking you now. Uh, I'm just asking you the question. Just answer it. Okay, and don't give much strain on this. Answer is very easy. Do you believe that sun will rise tomorrow, or do you know sun will rise tomorrow? Anyone?
And we know sun will
We
rise.
know. We won't believe. We know. No means what? Once, if you believe, say suppose if I say that there is a Santa Claus, so do you know there is a Santa Claus, or do you believe there is a Santa Claus?
We believe.
Yeah.
We believe means what? False. If you are believing anything,
Uncertain.
not uncertain, not true. Believe means simple speaking. Okay, believe means false, and knowledge means complete, certain, clarity. Okay? Uh, what we say, that is, this knowledge is something. So when we say knowledge, we are actually talking about scientific truths. Okay, and when we say scientific truth means we are considering the truths which are either absolute means the truth which are not time bound, and there are certain truths which are not absolute, they are time bound. Okay, they are time bound truth, and time bound means उस वक्त के लिए वो सच होता है, उसके बाद नहीं, उसके पहले नहीं. फॉर एग्जाम्पल, आई एग्जिस्ट is a truth, but it is true if I exist, else or otherwise it is not true. Yeah? You exist is a truth, but हमारे जन्म से पहले और हमारे जाने के बाद, that exists is not a truth. Existed is a truth. Okay, so that such type of things are there. So there are this thing, when you verify any of your belief and found that it is a truth, okay, it is a truth, then it is knowledge. And if you go on verifying something and you don't find anything, okay, you don't find anything to prove it, and you don't find any what you can say thing, then we can call it is a not true. That means it is a belief, it is not knowledge, it's just a belief. So when we believe something, for example, in physics, how many of you have learned this Bohr's atomic model? Physics?
Yes, sir.
Yeah, everybody. Is it a belief or is it a knowledge?
Knowledge.
It is belief. It's called as a hypothesis. आप फिजिक्स फिर से एक बार पढ़ लीजिए. Okay, they always says there are certain things which can't be proven, but if we assume them that they exist, we can define or we can clarify many things. Okay, that's why it is considered as belief, but now it is uncertain because you don't know whether it is or it is not. For example, when we consider string theory, we can have the equations, Maxwell's or Planck's equations, and when we consider it as a particle, we can have certain type of other equations, mathematical equations. Those equations can be used to show something, that is these things work. But if we go with one equation, other automatically become false. Just take an example of two type of physics. One is a absolute physics, Isaac Newton. Another is relative physics, Albert Einstein. So right now, if I ask you whether you are moving or you are sitting at one place, what is your answer?
We are sitting.
You are sitting at one place.
Yes.
Yeah, but now if you go with the Albert Einstein, it is not true because Earth is moving, it is revolving around Sun, and we are sitting on Earth, so we are moving with Earth, so we are not sitting, we are moving. We are not at the same position at any time, at any given time. We are not at the same position. We are maybe at the same position on the Earth, but because Earth is moving with Earth, every coordinate changes. So that is what we call as a knowledge. So it is not necessary that knowledge is always guiding. Knowledge many times confuses us, many times misleads us, and that's why whatever knowledge we have to choose the one which is optimal at that time. For example, let's say suppose I, we are given with certain type of say game to play, yeah, and we are having a different moves to do, so we have to choose the one which is best out of available moves. Yes, आप चेस खेलते हो, फुटबॉल खेलते हो, इवन इफ यू आर प्लेइंग क्रिकेट, तो आपको सबसे बेस्ट जो मूव है उसे चूज करना पड़ता है. आप सब मूव नहीं चूज कर सकते ना एक साथ. So that is what with the knowledge. Knowledge is generally come in terms of set. It is never come in terms of this is like this. So knowledge is always fuzzy. Knowledge is always fuzzy. There is no such thing in a knowledge which can be considered that this is one and you will not have no other option there. Okay, no, there are infinite options. The only one works, only one option works at a particular time. The same option may not work on the next time. उसके लिए एक गधे की स्टोरी सुनाते फिलोसॉफर्स दैट वो एक गधा था जिसको गधे पीठ पर उसका मालिक हमेशा कुछ न कुछ लाद के लेके जाता था तो था तो गधा ही एक बार क्या हुआ उसने उसके पीठ पर शक्कर की बोरियां रख दी और गधा चलने लग गया तो चलते चलते गधे का पैर एक जगह फिसल गया और नीचे तालाब था और तालाब में गिर गया शक्कर की बोरी के साथ ओके तो शक्कर के बोरी के साथ जैसे ही वो गधा तालाब में गिरा सारी शक्कर जो थी वो पानी में पिघलना शुरू हो गई और जब वो गधा निकला बोरियों के साथ बाहर तो उसमें से आधे से ज्यादा शक्कर पानी में पिघल गई थी तो उसके पीठ पर जो वजन था वो कम हो गया ओके सो नाउ द गधा गॉट नॉलेज कि ऐसे चलते चलते पीठ पर बोरी हो ऐसे चलते चलते अगर हम यहाँ पर आते हैं पैर फिसलता है नीचे गिरते हैं पानी में तो वजन कम हो जाता है दैट इज नॉलेज इट इज ट्रू मगर ये नॉलेज उसको हर बार सही नहीं हो सकता सो अगली बार जब वो गधे का मालिक क्या करता है उसके पीठ पे कपास की बोरी रख देता है तो वो हल्की होती है गधे को लगता है ये हल्की है अगर मैं पानी में गिर जाऊंगा तो और हल्की हो जाएगी दैट इज हाउ रोबोट वर्क्स रोबोट्स आफ्टर ऑल मशीन्स आर नथिंग बट द गधा ओके वी आर एडिंग आर्टिफिशियल इंटेलिजेंस टू इट हम उसको इंटेलिजेंट बनाने की कोशिश कर रहे हैं तो मशीन गधे के जैसे ही काम करेगा इफ यू डोंट प्रोग्राम इट करेक्टली तो अब गधे में तो प्रोग्राम फिट हो गया है सेल्फ लर्निंग जो बोलते हैं ना कि गधे ने सीख लिया है कि अगर पानी में गिरते हैं तो वजन कम हो जाता है सो दिस टाइम ऑल्सो गधा गोज टू दैट पर्टिकुलर तालाब ओके जानबूझ के गिरता है उसके अंदर अब क्या होता है कपास में पानी भर जाता है and when that donkey come out of the water what will happen all the cotton which soak that water okay become a lot more heavier than whatever is past position तो उसका जो पहले का नॉलेज था वो अभी काम नहीं किया एंड सच टाइप ऑफ नॉलेज इज कॉल्ड एज ह्यूरिस्टिक अपने शेयर मार्केट में इसमें जब भी आपको कुछ एडवर्टाइज आती है तो बोलते फाइनेंशियल इन्वेस्टमेंट आर सब्जेक्ट टू मार्केट रिस्क यस सो नॉलेज इज जस्ट लाइक सब्जेक्ट टू टाइम एंड situation so there are two type of knowledges one is what called as absolute another is relative or generally that relative knowledge is time bound and situation bound and when we want to go with the artificial intelligence programming we require to identify that and one thing is that if you believe something okay it is not knowledge knowledge is something which is always true okay either for the infinite time or for a small time belief is something which is never true okay which is never true for even a little bit of time but belief can help you to make many things and that's why it is necessary even in artificial intelligence and that's why I say that is belief representation and reasoning can give you the more accurate okay more accurate results that's why I think means a robot need to believe first that if he go on and before that robot programmer need to believe okay means without knowing without nothing and have to work on it and once it is justified when we can call it as a what can say knowledge but then they added here one later that is called as truth so if your belief is true then and then only it can be converted into knowledge otherwise not okay. So what you want to say this natural language inferences okay. Every smart student studies Tuesday evening okay, like this some sentences, how it works. Okay, so when we say such type of thing, knowledge with knowledge, we can say that it's thing. So here, this knowledge is generally represented like this. If I will just go with this natural language inferences, every student studies hard, but doesn't mean that therefore every smart student studies. Hmm? Is it true?
Yes.
Yes. बहुत वक्त लगा दिया. Tuesday evening, Jack either went to movies, played bridge, or studied. Tuesday evening, Jack played bridge. ये इन्फरेंस जो है ना, हम जब बहुत सारी चीजें बोलते हैं तो उसमें से कुछ किसी एक को हम पकड़ लेंगे. सो वेंट टू मूवीज, प्लेड ब्रिज, पत्ते खेला हो, या उसने पढ़ाई की. जैसे अभी मैंने समझो यू गॉट अ लैपटॉप. Okay, and you go to the YouTube and you have seen one movie, one few what you can say chit chat uploads, and then you have also visited to the some study material on YouTube channel. Okay. So what the person will catch, general observance is that whenever people go to social media links, मतलब अभी हम अगर यूट्यूब पर जाते हैं, so you'll find that is if you are having some serious discussion like this, artificial intelligence, one professor like me is trying to teach, or some enthusiast like you is trying to you can say dissipate the knowledge, you will find very few people are interested. Now let's go to the YouTube, and you will find some gada or gadhi. Yeah, they are just making some dance, making some faces. Okay, or just doing some parody. Likewise, are unnecessarily showing off the things which must not have to be shown in public. People will go and see that very uh, often. So this is what we call as the thing. So when we go on these inferences are based on what we can say heuristic knowledge, common sense बोलते हैं जिसको. Okay, so that is why I say that is generally whenever if someone know the Jack, okay, then they know that is Jack played the beat. तो हम में से कुछ कुछ लोगों को आदत ही होती है कि whenever we are alone, we go and do certain things. Okay. So these things are there, and this is what we call as you are trying to inference, और हम इसमें से कुछ मीनिंग निकालने की कोशिश करते हैं, ट्रूथ फाइंड करने की कोशिश करते हैं, एंड दैट ट्रूथ इज कंसिडर्ड एज अ नॉलेज. तो हम क्या बोल रहे हैं कि वी आर रीजनिंग दैट इज ऑन ट्यूसडे इवनिंग जैक प्लेड द ब्रीज, देयरफॉर जैक नीदर वेंट टू मूवीज nor studied Tuesday evening. Okay, so that doesn't mean that he is not a smart student. Maybe a smart student, or he is the smart student, but it's not always that a smart student will always act smart. कभी कभी होशियार आदमी भी गधे जैसा काम कर लेता है. Yeah, and you know that is only study is not something that we are here to do. There are many other things we require to do, but only thing is that we require to balance the things. So when we say this NL in inferences in knowledge base or representation, we have to be very background knowledge, some sentences and how we understand it. So we are actually trying to say John likes ice cream. Okay. Now what John likes ice cream? For example, if we say something, John likes to eat ice cream. For example, say one person say that I love animals. Okay, and why? Because he like to eat them. Another person say I like animals. Why? Because he love to nurture them. So the sentence is same, but inference or knowledge is something which is different. Okay, so maybe like to eat or something that we have to check. So I'm just again now what is memory integration? Okay, after seeing this sentence, okay, the sweet jelly was on the kitchen table. The ants in the kitchen ate the jelly. The ants ate the sweet jelly that was on the table. The sweet jelly was on the table. The jelly was on the table. The ants ate the jelly. So if you go with the things, what exactly happens? All these things, all these things automatically get vanished from our memory, for our memory. What our memory, our brain actually input, there are three: sweet jelly on the kitchen table or simply table, and who ate them? Ants. Okay, and last, they even we forget to do this also, and we go on doing what you can say the ants ate the jelly. So this is what we call as the memory integration. So uh, this thing, okay, this is the thing. So when we have all this is the sentence we generally build from all these, because we actually not uh, memorize everything. We actually not memorize everything. The same thing we have to do when it comes to artificial intelligence or computer programming also. We don't need to store everything into that computer. Only the salient feature. Only the salient feature, and based on that feature, the program must have to build the entire thing. For example, all these sentences are actually merged together to form this last sentence. समझ में आ रहा है सर सबको? Yeah.
Yes, sir.
So कैसे होता है means if I told you one thing one time, the same thing in a different way in the other time, same thing in a different way next time, what happens? You only pick up the important thing. जैसे अभी मैं आपके साथ बात कर रहा हूँ राइट ना, ये मैंने आपको बोल दिया कि ऐसा ऐसा ये है वो है, तो अपना जो स्टूडेंट एसोसिएशन का काम है वो पूरा हो गया है. नाउ व्हाट, यू ओनली रिकॉर्डेड दैट स्टूडेंट एसोसिएशन का काम पूरा हो गया है, बाकी किसी भी चीज के ऊपर आपके ब्रेन ने ट्रिगर नहीं किया है. दिस इज व्हाट आवर ब्रेन डू. जो इम्पोर्टेंट होता है उसके उसके लिए इट कीप इट इन एक्टिव मेमोरी, एंड जो इम्पोर्टेंट नहीं होता इट कीप इट इन अ पैसिव मेमोरी. और जनरली आपको आपको आपकी मेमोरी में से इन चीजों को अगर निकालना है, ये पूरे सेंटेंसेस, वी हैव टू डू द हिप्नोसिस. ओके, बट मशीन में ऐसे नहीं कर सकते. सो व्हाट वी डू इन मशीन, instead of saving in this in the such fashion like something, we only save the salient features and everything will be put in terms of relation. Okay, so अगर ये मशीन में सेव करना है तो ये इस तरह से सेव करेंगे इसे. Okay, okay, so what we will say, there is, we increase the size of font. हम क्या करेंगे, कहेंगे there is, and we'll say kitchen table and jelly. Okay, we can say sweet jelly. This is how computer program must save it. Then we will have the next relation after this, and that what we'll say again, there are or there is, because we are in this ants, and where, in kitchen. Okay, तो हम क्या बोलेंगे, 8 ants, sweet jelly. Okay, and where ants ate sweet jelly. Okay, there are ants in kitchen and there is a kitchen table. Okay, or you can say there is a sweet jelly on kitchen table. तो ये पूरा जो है that inference is here. So computer में जब सेव करते हैं, we are having a special computer programming language for this, which what generally called, and that special called as Prolog. Then you are having Lisp, then you are having C, then you are having Java, then you are having Kotlin, then you are having Python, then you are having R, whichever computer language is there. But especially if the computer programming language is AI enabled, it actually saves the information in such type of, what you can say, relationship. So this shows the relationship and this shows the two variables in which there is a relationship. Okay, so all these things are got together into 2 or 3 sentences. And so instead of saying all the data, what you say, the salient features, sweet jelly, kitchen table, and 8 likewise. And so from this, then computer can build such type of complete sentences. So this is the way generally knowledge is represented. Now, so what is the requirements to have a program for the program, which is generally called as a knowledge base agent? Okay, to build such a program, first is what is already knows. So that is called as a training data. It must first be capable of being told. आपको अगर पहले से पता हो तभी आपको कुछ बता सकते हैं. So you have to put new trigger beliefs into the knowledge base. Then you have to go true beliefs actually automatically deduce for itself a sufficiently wide class of immediate consequences. So if you want a program to be intelligent enough, you have to follow these 3 principles while completing that particular program. Then what is logic? It is a study of correct reasoning. It is not a particular KRR language. There are many systems logics. AIKRR research is there. So logic is something where you try to justify few things with the help of other thing. Now commonalities in logic are system for reasoning is there. It prevent reasoning from truths to falsities. Okay, so using logic you can even prove something false even if it is true. Okay, so language for expressing reasoning steps are there in logic. So these are the logics thing. When we go on studying the logic, we have the syntax, semantics, and proof theory. So syntax is something what we call as the grammatical rules. Semantic is something which are again the grammatical rule, but they are quite different. Means the same sentence or same thing may have the different meaning. That is called as semantics, and we have to have the proof theory for this logic. So there are the logics. The first logic is the propositional logic. Okay, so we'll see what is propositional logic. So what is a proposition? An expression in some language that is true or false, whose negation makes sense, that can be believed or not, whose negation can be believed or not, that can be put in the frame. So I believe that it is not the case that, and when we say, we call this as a proposition. Okay. So the examples of propositions are Betty is the driver of the car. Barack Obama is sitting down or standing up. Okay, like these are the proposition and these are the nouns. These are the actions. These are not the propositions. So if you go with these sentences, proposition, everything, you will come to know what is logic. Okay, do not contain a proposition. hi, why, pass, salt. Okay. This sentence not express proposition but contain one. Okay, driving the car like this, but it is question mark is added. So is Betty driving the car? So Betty is driving the car. You have the proposition there, and otherwise you won't have that. So motivationally is there microworld. These are the things. Standard propositional logics are there. Semantics, atomic propositions are there. So when we say atomic proposition, we can use the symbol any the for example any letter of alphabet P, any letter alphabet numerical subscript with a Q3 like any alphanumeric thing, and likewise it's an atomic proposition. So these are the well-formed proposition. Now you already have learned these propositions in your DMGT. Yes, discrete mathematics and graph theory. So now you know,
Sir,
yeah. So discrete mathematics and graph theory. That is the mathematics of computer. Actually, that is the mathematics which is helpful making computer artificially intelligence or making machines artificially intelligence. Because this gives certain type of what you can say thing or the knowledge to that particular or processing power to process the knowledge to the computer. So when we say that if P is then so is negation of P. Okay, for every what can say word form proposition. So here you have the negation of P and Q are you have the P and Q can have P or Q, you can have P implies Q, you can have P equivalence Q, and likewise. Okay, so these things are what you can say the propositions. Examples of these well-formed propositions are here. This is a negation of A and B. Okay, which is equals to negation of A or negation of B. Okay, so this is the proposition. So we can say that Tom is a driver, Betty is the passenger. So Tom implies Tom drives the Betty. Tom actually driver is dependent on the passenger. Passenger something. Betty drives Tom and not Tom is a driver. Like that. Negation of the things on the same. So we have the different symbols. We already have seen that we can use the physical symbols or something for symbolic artificial intelligence, and propositional logic uses this symbol. So these are the different symbols that can be used. Now, what is a computer readable syntax for this well form proposition? So, atomic proposition embedded underscores BT underscore drivers. So, you know that this is how we generally give the variable names and everything, and likewise to the thing. So, this is a print form. This is the computer form. Okay. So when we say this proposition, we have dependent on domain, independent of any specific interpretation model possible, because we generally use something which is asymptotic. Now, what is this statement in the language here? We use English, but you can use any other language for the same thing. Okay, so these are some example for this intentional carpool word semantics. That PT drives Tom, likewise, something alternative carpool is possible. So here we say negation of P. It is not the case that P. Okay, so here we have all this conjunction or disjunction, then conditional implication, antecedent, consequent, biconditional or equivalence. These are the symbols. If you go to the discrete mathematics book, you will get all these symbols possible. Now, extensional semantics are also there, relative to an interpretation, model, possible word, or situation, either true or false. So when we have this type of truth table, what we actually have complete possibilities. That is, if this variable will come true, what will happen? If that variable will come true, what will happen? For example, we have just seen here. So for this car, you are having this different variable: true, false, true, false, true, false. You get the complete binary code here, which was actually you can say process, and based on that, it will automatically work to find out the things. So these are the thing. Now, extensional semantics of these well-formed propositions are, that is, negation of P is true if P is false, otherwise it is false. So this is, you already know. So I think learn this. Okay. So if P is true, false, negation of P is false and true. So here you have the complete truth table. I don't think that you require any explanation on this. If you want explanation of on this, you can ask. Have understood this? Hello?
Yes, sir.
Yeah. That's why I first have given you the lecture for the what you can say, to give you the exact idea, because when it comes to mathematical part, many times things start to become a little bit dry, and what you can say, unicolor. So I won't say boring, but it start becoming like that. So what we can say, Mashe, that is, P implies Q, okay, is true when P is false, like this. So if the world is flat, then the moon is made of green cheese. So this type of thing are there. That is what we call, say, false belief are there. Okay, these logics there, that is, when you say P implies Q is equivalent to not P or Q. Okay, so these are the formal logic, and we are using the again, we are using this carpool. Betty drives Tom, Tom is driver, not Tom is the driver. Betty drives Tom equivalent to not Tom is the driver, and we got the truth table for this if you code the 4 bits. So this denotation can be used, computing denotation of this model. Now this is, here we are having the simple thing, denotation if P if QP. These are the computer language. Okay, and it gives us something like this thing. So model finding is there. Model satisfies well-formed proposition if the well-formed proposition is true in that model. So if a well-formed proposition P is false in a model M, then M satisfies negation of P. This is something. So we require to find out the model. Means it doesn't mean that is if your input is not satisfied. So this can be understood like that. This, that if you are asked to have a simple text box input here, text box, and in this text box you are say asking someone for mobile number. Okay, you are asking someone for mobile number, and here you are given the input option. So now if person types A, this text box must not have to accept that input. So what we generally do, we add some coding. Okay, so now this text box become intelligent enough to understand whether the entered input is a number or not. So artificial intelligence is this. You are getting?
Yes, sir.
Yeah. So this is what finding satisfying model. Now what this says, that is, if M is not satisfied by this, P is false in M, means here you are having this M model which is only accept the numbers. Okay, only accept the numbers. If A is not accepted, means numbers are accepted, but if you are adding a number, it will accept only 10 numbers, 10 digits. After that it will stop accepting any number, because mobile number is of 10 digit only. So we create that particular program, we create that particular logic, proposition, something, or what we call that program here in artificial intelligence as a model. Okay, now this model will accept the input of particular type or something, or it can what you can say sort out the input in a raw data and good data, something like that. So we are in this model finding with the spreadsheet that we can do. Informal model finding algorithm is there, which is exponential. We can go continued. We can use the different what you can say thing. Here is the list program for this W. Now here you can have in the list program this thing. Okay, we can have other program satisfiable, contingent, valid, likewise, and we can go with such type of. So this is a simple mathematics which generally used when it comes to symbolic AI and knowledge representation. Our entire knowledge representation is done either using prepositions or something like you can say discrete mathematics and graph theory, where you can have the salient features. For example, when we draw such type of thing, here you are having one node, okay, then here you are having the one node, and these two nodes are connected with certain relationship. Let's consider that this node is A, okay, or just consider this node as a Pune, okay, and this node as your hometown. So how your hometown and this Pune is connected by road, but if you want to come from hometown to Pune, or if you want go from Pune to hometown, you need to what can I say pay something to, yes, you need to expend something. So that is what called as a weight. So now what we have here, the graph. Okay, so this DMGT is the basis. If you learn formula automata and DMGT, that is discrete mathematics and graph theory, these are the basic fundamental math for representing and reasoning in the knowledge. Okay, so AI or computational engineering, computer science itself won't start without these things. Okay, so it's now already 4:30. How some So I think that you understood. If you not understood anything, you can say just put the message in Google Classroom that sir, in this particular lecture, these things are not understood by me. Kindly, you can say explain it once again. So we'll repeat that particular class or point once more time. Okay, and asking you people, now you are already here, so just showing you that I am having my YouTube channel TutorASRumale. I think day before yesterday I have put a message on our classroom, so you can become a little slow now. Okay, alright. So you can just show. It is blocked by college side, but if you go, you can visit TutorASRumale channel where you are having all the lectures of previous class uploaded for software engineering and other technical details also. So, really thankful to you for listening so carefully. But today's attendance was very short. Only half of you are in the class. Now, this attendance is what can say every month we are going to take the your attendance list and something. Then we have to go for detain. I don't want anybody to get detained. So at least maintain 80% attendance in your complete class. Okay. And now I'm ending the session. Thank you very much for spending this time
Sir,
with me.
can you please share the booklet